Let's start again. It is my pleasure to introduce Professor Ozdaglar, with a hard R, SM98 PhD 03. Professor Ozdaglar is the class of 1960 MathWorks Professor of Electrical Engineering and Computer Science, Department Head of Electrical Engineering and Computer Science, the Deputy Dean of Academics, and the Schwarzman's College of Computing. Professor Ozdaglar's research focuses on technical and societal aspects of large-scale data-driven systems. Her expertise include optimization, machine learning, economics, and networks. In recent years, she has investigated issues of data ownership and markets, spread of misinformation on social media, economic and financial contagion, and social learning. In addition, she has an active research program on large-scale optimization, especially in the context of machine learning. Her recent works develops robust, efficient, and decentralized machine learning models and algorithms. Her work has also contributed to the study of adaptive game theoretic dynamics and introduced alternative approaches to network games. Today, she's going to share a lot more about this and more. So please join me in welcoming Professor Ozdaglar.
Thank you for the kind introduction. Wonderful. Great. It's wonderful to be here. As Robert mentioned, I'm also an alumni, so I feel I'm part of the group. So it's wonderful to be here. Thank you. So it's wonderful to be here talking. I'm also a department head, and I generally, I was sharing with some people I know here, I talk about ECS, I talk about MIT. Today I'm very happy to be here with you talking about some of my own research and what I'm passionate about. And this is not just me. I think AI, generative AI is top of mind for everyone around the world. But at MIT, we think very carefully about, how could this be useful for the society and for humans? And that's what I'm going to be talking about. There's a lot of promise of this technology, but there are also places where we need to be careful about when we're thinking about this technology being deployed across society, across so many domains and applications. And so that's what my talk is about. So quickly, I guess, as I mentioned, the generative AI, large language models arrived almost instantly and definitely are here to stay. There's tremendous potential for intelligent, that's what people focus on a lot, but also flexible and easily usable complementarity to human decision-making and creative tasks. And this is, I think, one thing that sort of distinguishes it from many other technological developments we've faced is that it's such a broadly applicable technology. So we see it in programming. These tools write code, like pretty good, long codes. We see it in business. We see it in management. We see it in arts as well as in scientific discovery. So sort of the possibilities this opens up is just breathtaking. And I think the question we would like to ask is, can generative AI and LLMs indeed make this aspiration a reality? And my answer always is, I'm also very optimistic. I'm excited, but I'm a little bit more cautious person, I guess. And there is the promise, but I think we should also be cognizant that there are roadblocks on the way. And I think it's very important for us at this point in time to think about this development with the right vision, the right use, the right technical approaches, sort of the vision, I think, and all of this understanding will guide how we develop these technical approaches, as well as the regulation. So I'll talk not too much about regulation today, but that's another aspect that sort of goes hand in hand with many of the things. I'll be happy to talk offline if there's interest there. But let me start from the first thing I mentioned, the vision. And I think I find it striking to actually put all of this in context to talk about two fundamentally different visions for AI. And interestingly, both of these visions have MIT fingerprints. So the first vision is machine intelligence. This really, refers to Alan Turing's conceptualization of how the mind works. It goes back to Turing, but also you can see the Dartmouth project on AI. This is the workshop in 1956 where several MIT people joined. This is a small group of scholars that went into, a workshop, a few months, and there's this report which says, if, smart and dedicated people come together, we could really make progress on these questions. So you could see here Minsky, Claude Shannon, several MIT people playing an important role. So this vision really, I think I like explaining it best in terms of the famous Turing test. It really, asks, it's the imitation game. It asks the question, can a machine be indistinguishable from the human brain? So this is really about, reaching and surpassing human intelligence. So that's one vision. The second vision, let's call it machine usefulness or pro-human AI. This also, interestingly, has MIT footprints. It starts all the way from Norbert Wiener. It really focuses on or views AI as a useful tool that can boost human activities. So instead of, surpassing, this is really complementing or augmenting. And this is, I think, beautifully articulated and put into practice by computer scientists, which is a little bit different sort of thread of computer science. This is human-computer interaction. People like JCR Licklider, as well as Doug Engelbart. And I would recommend, actually, to sort of learn a little bit more about this viewpoint, to go back to Licklider's original paper on human-machine symbiosis. So I think this pro-human AI is, strikingly more important than ever today. And where does it sort of make the most impact? So I think we could look at a simplified history of human activity to see where this is going to fit best. Of course, from like the early times, 100,000 BC to 1800s, it's mostly centered on food production. From 1800s to 1970s, it's really industrial production. And from 70s to today, we're seeing growth of knowledge work. So we're thinking about design, education, entertainment, healthcare, planning, and all that. And generative AI really could provide the tools for humans to get better in knowledge work. And this was exactly JCR Licklider's vision from 60 years ago. This is just a quote from that paper, Human-Machine Symbiosis, I talked about. And this is from 60 years, I think it's 1960. The hope is that in not too many years, human brains and computing machines will be coupled together very tightly, and the resulting partnership will think as no human brain has ever thought, and process data in a way not approached by machines we know today. So basically, I think the message is when this coupling is designed in the right way, it will actually be better than humans alone or machines alone. And that was sort of his vision. I think this is sort of enables us to think about generative AI tools as useful to humans in better decision making, in being able to aggregate, filter, curate information better, and get better in performance of creative tasks. So to put all of this in context, I'd like to maybe give a few examples of how generative AI indeed can help human decision making. And you will see that all the examples I have are from papers that were basically published from a few months ago. It's all 2023. This is just the excitement going on in our community now. So how can we think about generative AI providing tools for humans to get better in knowledge work? And the first example I pulled is a technical one, programming. Pang et al. Actually did a nice study to show that software engineers, when they're paired with GitHub's Copilot, can actually complete certain specific coding tasks twice as fast. This is sort of the Licklider, when paired properly, it can do better than either alone. Another place where people are thinking about very much is, of course, writing tasks. These are, natural language-based interfaces, so it's very natural for us to think immediately about writing. And again, this paper I wanted to highlight because it makes the point I'm trying to make very starkly, I think. Noy and Zhang show that lower productivity workers, when given access to ChatGPT, improve performance in writing tasks. So if you, this is not, trying to get that task from lower productive workers. It's just thinking about how can I make those workers better. And finally, the final example is from Sloan, from some of our faculty here. Well, Bernofson is at Stanford now. The second one is Danielle Lee and Raymond. They did actually, I think, the first study of, large deployment of ChatGPT within a company in the context of customer support agents, and showed that when ChatGPT is used in a human complementary manner to provide information to operators, they've seen that actually performance, worker productivity, worker satisfaction, customer satisfaction all can go up. And again, this is, I think, an important example of how this, the use matters, right? How you use ChatGPT matters. They didn't just get, this is, let me just automate this. Let me use, ChatGPT to actually address customer issues, but rather gave information to operators to be able to deal with these issues better. So again, the common element in all of these examples is, can we use the better information provided by LLMs as input to human decision-making to increase effectiveness of human skills and expertise? So I also added here, I mean, this is another interesting and important use of AI in, safety-conscious or mission-critical applications. There's also, generative AI provides new avenues, or actually big promise in sort of safety-critical applications. This could be about identifying breakdowns in critical systems, such as public infrastructure or threats in cybersecurity, used in national security applications, including analysis of adversary strategies. This is, of course, again, a great promise. Can it be done? Well, it was done. There's a proof of concept of not really generative AI, but use of simple predictive AI tools and data analysis in January 22 for identifying Russia's invasion of Ukraine, as well as the exact lines of attack ahead of time, 4 months actually before it happened. And this was reported by General Stanley McChrystal in Foreign Policy in June 23. So this is all great success, I think, but the success may hide also major fault lines or roadblocks, which I would like to highlight in the rest of the talk. Sort of, I think I'm motivated with a positive, outlook where this could be used. And, it's important, I think, to all those examples I talked about, how ChatGPT or how generative AI is used in these different applications. I think there's a lot of debates around promise, existential threats around AI. I'd like to basically highlight 4 distinct but important roadblocks that are not 10 years down the road, that are in front of us, that we should really start addressing, and hope that with the right way of developing the technology, we will basically go in a direction which sort of will take us to the right place in terms of their use. So these roadblocks, the first one that I've been trying to, I think, highlight is excessive automation rather than input into human decision making. The second one that is sort of, I think, less probably highlighted in discussions is unforeseen consequences of better information from humans. We feel, this is sort of, I think, the naive approach, even in a lot of research papers. If you have more information, more resources, things will be better. That may not be the case, especially in the context of information and many agents. It may lead to greater conformity, less diversity, and unexpected vulnerabilities that can be exploited and create some unexpected breakdowns. The third one, which is also, I think, extremely important, and something I emphasize a lot in my own research, computer scientists, machine learning experts, we work a lot on developing algorithms, properties of algorithms. Let's make them faster, let's make them better. But at the end of the day, these will be used by humans. So to be able to get performance out of these algorithms, it's important that we have an alignment between, especially if these are used as decision support tools for humans, we need to make sure that there's an alignment between how humans perceive the information provided by these algorithms and how it impacts their decision making. So there may be incorrect perception and processing of AI inputs. And the question that I would like to ask is, can AI systems indeed exacerbate blind spots or biases that humans have and actually not lead to better performance? And finally, I'll talk about misuse, misinformation, and manipulation, which is not new. These things have been there forever, even before AI, before generative AI, and now. But I would like to just point out sort of how it happened and why I'm sort of would like to be cognizant about this enormous promise of generative AI may actually amplify some of these issues that we have been facing already. So I will now give you basically some parallels or examples from previous waves of AI technologies for these 4 roadblocks. I hope you will be able to relate to them. These are things that we've been facing very much in use of this technology. And then I will try to argue how these actually could be amplified with generative AI. So the first one is, as I mentioned, automation. So this is really about, automating tasks instead of, using it in a way that can leverage human skills, which was key in the examples I have mentioned. So it may be, this is such a powerful tool. It could do phenomenal stuff. So it may be very tempting to use it just for automation. And my point is, I think we should be careful with this because this will not unleash the full potential in complementing human decision systems and risk possibly bad judgments in mission-critical applications. So there's been a lot of work on this particular question. MIT has led a very successful future of work working group. Some of you may have heard about it over the past few years. There's a lot of work that many people across the campus have put into to understand this. And there's actually evidence that past digital technologies, starting 2015 and onward, actually have been used for automation and have had adverse distributional and wage and inequality consequences. So this is a chart that I wanted to share with you from Asemoglu and Restrepo 2022. It's very interesting. So let's maybe spend a few minutes reading it together. There's a lot on the chart. So there are these bubbles. These bubbles sort of refer to different demographic groups. So orange is those with graduate degrees, blue is those with college degrees, purple or pink is high school graduates, and green is the high school dropouts. And the size of the bubbles is sort of the size of the demographic groups. And on the y-axis, this is change in wages. So there's 0 here and negative, as you can see. And on the x-axis is basically how much of the tasks carried out by these groups have been automated by these technologies, predictive AI technologies. And you will see that in that sort of right side of the chart, the high school graduates and dropouts have been displaced with significant wage consequences. So those are the groups that are most affected by automation and suffered wage declines. So yeah, automation is great, but we need to, I think, be cognizant of its impacts, both on inequality and overall productivity. The other evidence, I think, is that this is an interesting one, and I picked an example which drives me nuts, the self-checkout. So that's, I don't know how many of you use it, I don't, but it's sort of, I think in several of these papers referred to as so-so automation. So it's automation, but it's sort of automating tasks in which the productivity is just a little bit maybe greater than humans, leading to very little gains. And possibly more annoyance for customers. So the worry, I think, those are things that have been, this is not generative AI. These are really, more automation, predictive AI technologies. But the worry is LLMs seem to be going that way. So if we're thinking about writing or analytical tasks being automated, then that's exactly, I think, the issues that we have seen in these other works that I've highlighted. And this is happening in companies, some companies. We're seeing the Writers Guild strike, the sort of ownership or the copyright issues in the creative output generated by these AI models is going to be crucial to figure out, because what these models are trained on is the creative work of many, many workers. So how would that sort of be taken into account? How would these individuals be part of? It's important we include this in the training data so we have good models, good AI tools. But at the same time, we need to find a way to make sure those workers can be properly incentivized to be part of this system. So the sort of, I think, this is, it looks like all bad, but I think there's also, in this literature, solutions to these issues. And that's basically this augmentation, complementing, but also new tasks. So I put here one example from Henry Ford's Rouge plant from 1990s. So we've seen automation in the industrial transformation. So this shows actually a lot of the many automating machines. But this also shows that humans are working with these advanced machines on technical tasks. So I think the way we should be thinking about this is not only automation, but also creation of new tasks so that workers are reinstated into the production process. And the promise of LLMs and generative AI more broadly should be in this type of new task creation and enabling humans to work hand in hand with these tools. So that's the first roadblock. The second one is what I've just mentioned about unforeseen consequences of better information. All my research is actually motivated by my own experience. So this is basically what I was telling you about. More information is good, but the point I would like to make here is it may not be good because it brings some systemic unforeseen consequences. And this is really GPS. I have kids. I drive them in the morning to school. I sit in the car for a long time. This is when I started working on this problem. So GPS was, one of, we don't think of it as AI, but it is. It's one of the first intelligent systems. It gets a lot of data from many, many drivers, aggregates them, distills them, and gives recommendations to users. So this is very much AI. And its use was supposed to be beneficial for the drivers, but it may not have been that way. And there's here, some data from London. The problem has been, GPS indeed provides you information about new roads and new, shortcuts you may take in your drive. However, traffic is routed so much towards minor roads, which are not really congestion sensitive, that it actually made things worse. And my work here basically from a few years ago looks at when this happens. What kind of cities, what kind of transportation network structures actually has these kinds of issues. But here there's some actually data that shows that if you look at London traffic, roads and motorways from 94 all the way, this is basically, think about it as a proxy for how much traffic there is on these motorways. That hasn't improved much on motorways, maybe a little bit, but on minor roads we're seeing a huge increase. And overall, when you look at it, it's actually not improved by much. And then, of course, COVID hit and everything stopped. But So this sort of aspect of informational unforeseen consequences, I think, will be intensified by generative AI. And I picked a few examples for you. Some of them actual examples. Some of them I cooked up, but I think it could very much happen. So as I mentioned, there's greater conformity and informational herding, right? This is the herding of, GPS gives us this other road that nobody is on, but then it gives that information to Whitney, to me, to Robert. We all go there. Oh my God, that's worse. So that's sort of the informational herding. If everybody starts turning to LLMs for information, this will mean that we all have the same information, and this will reduce diversity. It may lead to, if one LLM is actually more powerful, one model, one company's product more powerful than others, we will see more monopolization of online commerce and control of data. And the one that I find very hilarious, and we're very much working on this now, is these feedback effects between AIs and humans. Like AI gives you a recommendation, you do something based on that recommendation, AI gets, because that creates data for AI gets trained with this. I'll talk about that a little bit more. Here I want to talk about AI hilarious interactions. And this is the example on that side, Google's Bard and Microsoft's Bing citing each other, incorrect information, and that gets amplified. And this really happened. I believe this, where did I get this? It was from an article a couple months ago, and this was basically Microsoft's Bing responding to a very simple query, citing misinformation produced by Google Bard. And the question was, is Bard shut down? And then Bing said, referring to a tweet by a user in which the user asked Bard, are you shut down? And Bard said, I'm already shut down. And he was actually citing a comment that was made in Hacker News, I think, by someone who joked about it. So basically, he took that from there. Yeah, I am shut down to the user, and that was picked by Bing. So think about now, right now the current state is that these models are trained by lots of the internet data, and that fixes the model from there on. So in the future, not too far future, we're going to see these models being real-time trained by the data. So they will basically, they will be trained by internet data, they will start spitting lots of information to internet, and they will continually be trained by that information that they have produced, and that's exactly the feedback effects that I'm concerned about. This is another example where you may be asking an LLM, is this policy effective? LLMs make mistakes. I will come to that in a second. It says no, and the future human communication is that policy is not working, and LLM's new training data is policy is not working. So think about what that might mean for the information we get from these tools. Okay, so the third, how am I doing in time? I'm worried I'm just talking too much. Good, are we good? Okay, so the third roadblock is, what I mentioned about, again, this interface. How do we design the AI-human interface? And I just want to point out a few examples where cognitive misalignment may lead to issues, not necessarily, performance gains. Humans input into human decision-making is useful to the extent that humans use it correctly. You may give them phenomenal information. If they don't interpret the informational content properly, they will not use it properly. So I would like to give maybe two examples. One is actually from a few years past. This is predictive policing. And this is actually deployed. Predictive policing algorithms use very dynamic and granular crime data to decide on how police resources should be allocated across a town to be able to best prevent crime. So this is great, because you have a lot of data that these algorithms can have, and that could help the police figure out where to go to be able to best intervene on crime. The issue is these algorithms are fed data that is coming from discovered crime rate, right? So think about, I think this says Auckland. This is one example where the figure on the left shows discovered crime rate. When you feed that data into the algorithm basically will think these are the places where crime is most prominent, and will keep sending the police to the same locations over and over. So that's basically the Predpol's recommendations. whereas the true crime rate actually looks like this. So without exploration, without, if it's just based on actual crime data, you will not be able to get good representation of what crime is. But okay, this is one problem. The other problem I would like to highlight, which is I think even worse, is you tell the police there's crime in this location. So police goes there with the expectation to uncover crime and actually may put overemphasis on this recommendation, saying, I'm going to actually make arrests, I'm going to uncover illegal activity, much more than warranted. So this paper that I'm citing here actually shows that the outcome of all this has been, more crime in certain locations, less crime in others where there may be actually more crime. So you can see all these feedback effects playing a role. So that's in policing. The other one is from a more recent application, and this is again some of our colleagues from MIT. I picked a lot of MIT papers. So this is basically showing that when you use these decision tools in healthcare and give recommendation to physicians, they put more weight on information duplicated by AI. So this is exactly what people refer to as confirmation bias, right? Oh, exactly, that's what I thought. And then systematically underweigh new information recommended by AI. So how do we deal with this, right? How do we make sure that this information, there's a wealth of information provided there, but how can we make sure that humans use it properly? These issues are in the context of predictive AI. Generative AI will actually, I think, completely amplify all of these concerns because many more sectors, many more people will be relying on these recommendations. Any feedback loop will be amplified. I haven't talked much about this, but there's also great evidence that AI recommendations may have fairness or bias issues with respect to different demographic groups. These kinds of issues may be more widespread if humans use generative AI more, then biases in AI resulting from input data or architecture will become more widespread, and bias may actually become more legitimized because humans trust generative AI more. Biases basically will be more legitimized. So this is one example I picked, which says that the AI is used in many places for helping with hiring decisions. It has been documented that that's very effective. It's sort of because AI can sift through information better than any of us can, right? Tons of information. But that also leads to issues. And 2/3 of Americans would not want to apply for a job where AI is used to help making hiring recommendations. And there's some also study of how this changes between, with race and ethnicity and so on. Okay, I'm worried that I'm maybe talking too negatively about things. I will come to a point where things will start turning more positive. It's just, I think we should be cognizant of all these issues that could happen. So the fourth roadblock and the last one is misinformation, which I think all of us, have been seeing, experiencing thanks to social media. And the concern here is online platforms, providers, and even users can use generative AI for manipulative purposes. So social media, of course, is a beautiful example from the past. It is changing completely how we communicate, how we make friends, how we form opinions. It was in the late 2000s such a big promise, right, for democratizing this communication, bringing people together, enabling people to express their views freely, exposing us to a diverse set of views, and so on. It's also become possible, this power has become possible because of AI-powered recommendation algorithms. This is another place where, I don't know if sort of it's immediate to see that it's all AI. Otherwise, this much information is not possible for these algorithms to connect, boost that information available from all around for individual feeds. So that was the promise. However, sort of what this led to is recommendation algorithms that actually choose to promote more emotion raging or extremist content and create this so-called filter bubbles. So where basically it tries to cluster like-minded individuals because that kind of like-mindedness causes people to be more on the platform itself. And the root cause for this, there's a lot of works on this, is really the business models of these companies and platforms. They very much rely on the digital ads, individualized, personalized digital ads to keep you on these platforms. And that means that basically they need to maximize user engagement, attention, and hook you to these platforms. And what is the best way to do that? Well, you send some news information that's, individuals find, emotion provoking, and that feedback, that makes people stay more on the platform. Then the algorithm learns that and does more of the same. So that has been one of these issues. And what would generative AI do to this? Well, it could massively expand how information is presented in misleading ways. So this is from May 29. World's biggest advertising agency, WPP, has teamed up with NVIDIA to use generative AI in creating their advertisements. So what does this mean? This means that, this is hugely powerful technology, right? That means that it will enable them to create first of all, large collections of advertisements, and those that will be perfect for you. So it could put the same red car you're looking for on a street in London or on a beautiful desert, depending on what will appeal to you most. So this will be creating essentially ads that are more immersive and tailored. In the short run, this may amplify amount of misinformation, but in the medium run or longer run, we may be in a world that Hannah Arendt foresaw as, if everybody lies to you, the consequence is not that you believe the lies, but rather that nobody believes anything any longer. So this means essentially that democracy will no longer be possible because there is no common beliefs, nobody believes anything, and there's no collective action. So, okay, that's it. No more roadblocks. So how do we overcome the roadblocks? The good news is a lot of people are thinking about these issues, working on these kinds of questions, and very much coupling technology development with this kind of emphasis. So I'm very actually proud about our community tackling these questions in an integrated way. We would like to avoid excessive automation. Humans being in the driver's seat is key. We're not going to change that. Human judgment is key. Excessive automation at any stage of AI risks losing human judgment. Many of the problems I talked about comes because of these feedback effects, because these models are trained on lots of data. I think my colleague yesterday, Alexander Madri, maybe talked about this a little bit. It's on all of internet data. So there's now a lot of effort for, actually, can we develop these models with much higher quality data and with control on how these things can be properly accounted for. And also there's much research on developing tools for identifying problematic content. People talk about, can we use watermarking technologies? Can we actually disclose the source of this data that's coming to you? So at least that source origin information tell you about how misleading these things could be. And can we actually use AI to help us to identify this low quality data? One caution, again, I can't go, it seems like I make a cautious statement on everything I say. So watermarking, provenance disclosure are good techniques, but it may also have unforeseen consequences, for instance, the implied truth effect. This is also another paper from Sloan, Dave Rand and his group, that not labeled misinformation may become less likely to be detected. So if people think that things are watermarked, not everything will be watermarked, but the perception of the human will be, this is not labeled as misinformation, so this is truth. So actually their field studies shows that this may lead to even increasing misinformation in some cases. Not all the time, but I think the caution is we have to be careful when designing the right intervention strategies. Okay, this is the other sort of overcoming the roadblocks, better techniques. You probably are hearing a lot about hallucinations, right? These models spit out phenomenal text as if it's written by someone who is completely knowledgeable on everything, but they sometimes also hallucinate facts. This is one that I think many people try out, to see when you start first using ChatGPT. I tried for bio for myself, and it's correct mostly. There are a few places I marked. I'm absolutely not born in 71. I did not do my degree in Bilkent. Those dates are also incorrect. The most hilarious I found was the last one. It says I held a lot of administrative positions, and in 2021 I became the Dean of School of Engineering. That's absolutely not true. That's my boss, and I hope he doesn't see this. Anyway, I thought it was funny. Hallucinations are an important problem, but right now a lot of people are working on this. This is a problem that can be solved. I'm not worried about that. But I think it's the tip of a much more deeper problem, which is lack of reliability. Ensuring that answers to complex queries is based on reliable information. That goes back to, training these on reliable data. If, for instance, quoting articles that claim COVID vaccines cause excessive deaths, then the answer will be something around that. So this sort of very much goes into the problem of more reliable, better curated training data for actually developing these models. And this may need fundamental architectural changes, shifting the training. Again, higher quality data is key. So what other techniques? People talk a lot about interpretability and transparency. These are black boxes. They give us recommendations. We don't know why. So this is unfortunately a much harder problem than hallucinations. The reason is the research community cannot even agree on what we mean by interpretability or explainability of an AI tool. I mean, we don't know what explainability means when it comes to a human. How do we explain our decisions? How do we explain ourselves? So this is all, I think, very deep questions. We need to first, both conceptual questions as well as technical questions. It's harder. The second point is, what I just mentioned. These are large models, billions, trillions of parameters trained on unbelievable amount of data. So that training takes a long time. But then you train the model, fix the weights. How do you then, think about incorporating new information? Because information keeps changing. New things happen. Prime ministers change. When you ask this model about some information, you would like to be able to update it. So this is another important aspect. How do we update these models without training them from scratch? It could be for incorporating new data. It could be for correcting undesirable behaviors. Or it could be because I'm going to get this general purpose tool and apply it in a particular domain, let's say in healthcare. So then I can maybe use more healthcare-related data to actually, make it more specialized or personalized. So this is done through fine-tuning, changing weights necessary. So I put a little bit, some ideas. What people do is you have this big models with lots of layers. So people think about maybe I freeze all layers. Maybe I just leave one flexible, and then I train that one layer to be able to incorporate the new information. Is that sufficient? I have no idea, but that's something that we're working on. And the final thing is, we're thinking about these large models, centralized, but we also have a lot going on with edge computing. Much of the data is actually aggregated in the edge by smartphones. We have a lot of local data. So the question is, how can we think about training these models using decentralized techniques with some cloud or centralized oversight, such as what we do in federated learning. Okay, so I'd like to maybe just add by a few more points. The first one is human training. AI literacy is extremely important. No matter how powerful a tool, these tools can be no better than humans in charge. I make this point that, I'm an engineer, computer scientist, but these problems are not just technical problems. These are very much technical and social problems. And therefore, it's important that we do multi-skilled training for our own students, for decision makers. We should not be sacrificing social and contextual skills for technical ones. Developing the right ethics is extremely important, and I think US here has an important role to lead. It's ethical use of data, developing the right norms on how data can be collected and analyzed. We're collecting data. These tools rely on a lot of data from a lot of individuals. What is and what is not allowed? I think that's important to set the norms on that. And the right norms will ultimately help with higher quality data and better understanding of tools. So I talked a lot about, I guess, cautions. So it sort of feels like there's not clarity in the research community, in the development of these things about where we're heading. There are many reliability and unintended consequence concerns. But the good news is I totally believe a better structure and ecosystem of AI is possible. It may require a different architecture, much greater effort placed on human complementarity, and also government plays an important role here in shaping this development and helping, more public-minded also people having, the resources they need to be able to develop and, investigate these models. So with that, I think I will conclude, and thank you for your attention. Yes, I think so. I think I'm okay.
Okay, thank you, Professor Ozdagla. Very fascinating discussion, very provocative and insightful. We have time for a few questions, so any questions from the room?
Would you like to take them or me to take them?
Do we have mic runners? Yes. Let's start over there.
Okay.
Yeah. Hello, thank you very much for the conference. You ended speaking about regulation. What are the key features that a good regulation should have?
That's a fantastic question. I was actually telling Whitney, maybe I should have spoken another hour on regulations, and we are thinking very deeply about this at MIT. It's not easy. I mean, many countries around the world, EU, and others have been thinking about these questions. US actually has been a little bit behind in these conversations. The EU has had a lot of, conversations on this. But things have we're observing that things have gotten stuck because there's a lot of emphasis placed into defining what AI is, defining high-risk areas of use, and not agreeing on those. So those are places where there's a lot of discussion going on. We've had a group that we convened over the summer, a group of MIT faculty from all parts of MIT, both CS, Sloan, economics, political science, to discuss these questions. I think one way of going about it is first, instead of completely coming up with new laws and regulations, thinking really about, wherever we have laws to regulate human behavior and use cases, we could also do the same for the use of AI in those places. So this is sort of thinking about, again, AI being not something completely different, but really complementing humans' use of these tools, and thinking about wherever we're regulating human behavior, we should actually thinking about regulating AI in the same way. So just an example, I think, which is very sort of makes this clear, I think, is we're not allowed to make medical advice, if you don't have a certificate or if you're not qualified to do that. Humans are not allowed to. ChatGPT does that all the time. That was what hooked my mom. When I showed her, look, Mom, ChatGPT, and she was like, oh, can I ask this, drug, the effectiveness of that? And that's the first thing she started sort of interacting with. So anyway, that's a joke, but so that's one very clear place, right, where we can start thinking about regulation. So there are then many other questions, because as I mentioned, AI amplifies what humans can do. So if you're thinking about, being able to fake news, right, the example. So AI will make it much easier to manipulate. AI will make it much easier to collect data. So there's also places where we need to think about further. And there's more to think about also, because I think the key is thinking about what AI does, not so much what AI is, and then think about regulating the uses of that. So then it becomes, easier to think about, I think, because you're thinking about, critical domains as you define for humans, and then go from there to think about how to regulate it properly. Other things that we need to be careful about is these, foundational models, the large language models, because they can be used everywhere. So it's not, you take that. This is the other aspect of regulation. We think about AI system, but when we say that, it's generally a stack of many, many components. So how do we actually think about how these components interact with each other? If something breaks down, who has the liability? So all of these questions are, I think, extremely important, but we're thinking about it, and we're trying to sort of approach it from both technically informed but practical policy recommendations. Thank you.
Thanks. So AI has to become smart, so it needs to be trained. And it seems that the data that's coming in is mostly kind of crowdsourced data, looking at the things that I would call visible data. But there's a whole realm of data that is perhaps visible, but we're not so aware of. Things like body language, or maybe what my mother used to say to me, tone of voice, Bob. And these things are also used for decision making, not only when we meet people,
yes,
but also they're used commercially. For example, typography is something where you look at letters, but you don't think about the typography, but it affects your decision making. Designers use that, or writers for the GPT thing. Am I going to drink a cup of coffee, or take a cup of coffee, or have a cup of coffee? So these kinds of unseen or maybe unaware data are things that could be used to override overly technical or hallucinative things.
yes,
But I don't hear much talk about this kind of data. How will that data be used?
Available, yeah.
And also, how can it be used to train AI?
Yeah, so that's an excellent question. It goes back to my emphasis on, data matters. Data is very important. So one thing I'd like to highlight, though, is, right now, that's very important because the interaction, when we're interacting as humans, we also make mistakes, but through that interaction, we actually correct each other and we come up with some consensus. That's not what seems to be happening with the use of these models now. I'd like to make one point, though, because it's actually a very interesting one. So this whole wave, or just tremendous interest in generative AI became prominent with the introduction of ChatGPT into the market. It really had not many technical novelties compared to what we knew 3-4 years ago. The sort of, I think, reason it became amazingly popular is it had this, first chat interface with everybody. Everybody can use it. It made it available to everybody. And one sort of very interesting and smart thing that OpenAI did, which is sort of RLHF. This is reinforcement learning with human feedback. And that sort of played a big role in the training of these algorithms. And exactly what you were mentioning, these were trained on this internet data without getting any of those cues, what human preferences or what human conversation looks like. They had no idea. They just get the data. They have that knowledge. But then this human feedback part essentially was, they brought in humans into the room and looked at the trained model. And then, the model they asked questions, and the model gave many, many answers, and human basically scored those. And the models learned human preferences through this process. So this was a proxy for getting these preferences into how models know how to interact with humans. It's not a great proxy, because, who do you bring into the room? Like, that's really very much dictates how these things interact with others. So there's a lot of questions around bias introduced even through that process. Are we capturing all kinds of preferences this way? Are we capturing only partial preferences? How do we actually make this process better? But there are ways of doing it, and I think it's very important to think about it as we move forward. But that's a great, great consideration. Thank you.
Over here?
Oh,
Hello.
no.
Oh. Okay, thank you so much for the wonderful and terrifying presentation. Is
I'm
there
sorry.
is there a language bias, and is there a bias over English being the predominant input language?
This is primarily done in English, but I think right now there's a lot of work that goes into multiple languages, and for many widely used, widely spoken languages, same type of powerful models are available. I'm not aware of language biases in this context, but there's work that actually makes it available across all possible languages.
Hi. Hopefully it'll be quick. Thank you so much for the presentation. I personally am terrified about your reliance on human judgment, right? I mean, all of us, at least in the room, will remember the before and after ChatGPT, right? We're old enough to do that. Kids will just grow up with it as the norm. How do you continue to rely on that judgment, and where we know that human judgment in general, is not as good as maybe we wish it to be?
Yeah, human judgment is not perfect, absolutely. But humans have things, objectives, desires that are not captured by these models. So I view that as two imperfect agents. And I think my point was we need to make sure we couple these. I mean, because these machines do not really have objectives, emotions, desires. It basically does what you program it to do. I mean, it learns. That's the difference from the previous software technologies. It's not rigid in terms of it spits out a, sort of an algorithm. It actually uses the data to learn and go beyond what you have. That's the beauty of it. That's why we're able to see all these flexible behaviors. But at the end of the day, it basically knows what you train it on. This is why I feel it's important. Going back to kids will grow with this, norms will change, absolutely. Norms will change, but the worry right now is this technology is moving faster than we're actually developing the norms. So I think that's the point I'm trying to emphasize. We need to, I'm not at all, there are people who believe, there should be pauses or things like that. You can't pause technology, but we need to be cognizant that norms, institutions, which generally govern how humans interact with anything, technology, anything else, that needs to come hand in hand. And I think the worry I have, or the attention we need to put on this is going too fast, and things are sort of not catching up as fast. Over.
In sort of a follow-up to that question, we talk about ethics and developing a code of ethics. In my post-career career, I'm a politician. And that should be the most reviled thing in the room. The history of a scientist coming up with codes of ethics and then the leaders following them is terrible. So, so saying we'll come up with a code of ethics by itself doesn't work. How are you going to make it work if you do that?
Yeah, that's an excellent question. That relates to also my concern. I didn't talk about this so much. Another concern I have is the centralization in the development of these tools, right? Whether it's, that was sort of relates to my previous answer. So there are few companies developing these tools. They're putting a lot of effort in, training them with human feedback. But I think these kinds of norms should be developed by a broad set of perspectives, because this will be deployed in many places in our society. I feel, or the approach we take at MIT to handle that is it should not be just technologists. It should be, philosophers, it should be politicians, it should be many different perspectives coming together to come up with discussions and try to come up with sort of what we would like to do for the development of this technology. It won't work. Let's discuss that. I'm hopeful.
We have time for a couple more questions. Why don't we go all the way in the back?
Thank you very much for sharing that. Along the line of the equality of the kind of how AI is deployed, the question comes up, and because of the different cultural settings that we operate in.
Yes.
My question in terms of, it's along the similar line as you're saying,
Yes.
the many things that need to be incorporated.
Yes.
How is it conceived of at least incorporating the differences in the cultural context,
Yeah.
in addition to the beliefs that are part of those systems that we're operating in across the globe,
Yeah.
and using the also the, I guess, as the foundation, how AI is received in those settings there.
Right.
How is that more effectively approached, and how do we begin to bring those conversations into the communities that AI is being implemented in?
I think the first thing is the realization even, and this is very much, I think we're going around the same, like, you know, if you just train or, you know, fine tune using the data you have, using a few individuals you have, that model will just adopt the norms, beliefs of that group. So this is, I think, a big issue in terms of how the development is taking place now, because it's in the, you know, the entities that can develop these huge models are just a few right now. In academia, we're feeling this very starkly. We are working on these questions. Our goal is to be able to have a more fundamental understanding of how these things work, but we don't have access. You know, some of these models now, you know, the largest or the most recent ones, they're closed. We don't know how they're trained. We don't know, you know, many things have, you know, I mean, we have an understanding of the fundamental steps, but there's a lot of things that go into, you know, fine-tuning or figuring out these models. So I think the point I'm trying to make is, first is a realization that this is a problem. Second is a realization that, again, going back to the previous question, how you fine-tune these matter a lot. And we need to be cognizant about capturing the cultural norms, the preferences in a broad and diverse way possible, both here but also globally, because things change, and you know how these things interact with different societies change and matter. I think my answer is the same. It won't work maybe, but we really need to bring lots of people together in conversation, both within our country but also globally, to be able to really guide the development of these tools, because it will matter. So I hope that answers it partly. I don't have an answer, but I know this is an issue. And we are actually working on technical tools to be able to do the human feedback aspect. So how can we minimize biases? There's technical work going on there right now, but I don't think we're there.
Let's take our final question from this side of the room. Please use the mic. Please use the mic. It's right next to you.
I'm concerned that we have an accelerating, perhaps exponential, technological dependency and the impact it has on society. I mean, we obviously know the effect of calculators and word processing and things like that. But now we have things that we can't distinguish in general. For instance, the classic one is weather prediction, right? About the time when I came as an undergraduate, the only weather prediction available was the color of that light across the river. Okay?
I know.
Today we have something called Futurecast, and they have it show you evolution of satellite and radar information, but then there's a little point, if you don't notice it, where it transitions from history to prediction. And people just see this as a continuum without realizing there's a transition occurring at that point.
Yeah, so it's a very good question. I think right now we're at another big transition, and I think I made the point earlier. The thing we need to sort of pay very much attention to is we have this tool which is applied everywhere. in many, many different domains. And many people don't realize this yet. And the examples I gave where AI is a core piece of it, people don't, I think, realize that this is a core piece of it. It goes to, I think, this is going at a very fast pace. And, we need to, I think, just be cognizant and attentive. Maybe not completely, timid, not audacious, but something which is in the middle, being very attentive to its development and making sure we can actually, build the right norms around it, build the right values and societal values embedded in it, and maybe move from there. So I don't have answers for everything, but I think the good news, this is why I probably terrified you with lots of, cautious, but the good news is I think the starting point is to realize these issues and, really start addressing it collectively as a community. So.
Please join me in thanking Professor
Thank you.
Osterglass.
Thank you.